Hi there, welcome back. This time we've got something really special on the bench here, and this was quite a surprise because, quite honestly, I didn't know that this thing existed. When I was told that a friend of a friend of mine had a Pioneer tube receiver with left and right tuning and with rumble filters and scratch filters and all that sort of thing, I just didn't know they existed. So I was quite keen to get started on it, and it actually came as quite a surprise. This thing is nuts. It's the way this works is absolutely unconventional. This thing is a Pioneer SM-G204B Stereophonic Receiver. And it also comes with a few extras, but if we stick to the receiver part, it gets very interesting. You see, we've got tuning on the right hand side called tuning B. It's got its magic eye over there. We've got tuning on the left hand side, tuning A, and it's got its tuning eye over there. So what can we make of this? Well, it's actually got two tuners. In fact, it's got, what is it, four tuners? Three tuners in one. And I'll explain because it gets a bit complex here. We start on the A side, tuning A. What we have here is we've got medium wave on top and short wave at the bottom. And you can select between that using this switch here, medium wave, short wave. Now that applies to this tuner here. And interestingly enough, when we look at the schematic, you'll see this is actually a completely independent tuner. It does do the tuning for both the medium wave and short wave in one. In other words, the switches in the respective coils and so on. But it is one completely independent tuner switched on there. That's the A. Now on the B side, tuning B, we have medium wave and FM. And this is a strange combination because what they were trying to do was to give people a stereophonic experience with FM mono when this thing first came out. Now this thing is from 1960, was it 59, I believe it is. So stereo FM was not the thing then, but they were experimenting with it. And what these guys did at that time was making this tuner as open to all possibilities as they could, because they didn't really know what was going to happen with the stereo FM phase, if you want to call it that. So they just built a tuner that can handle everything. And what they've done here is this particular medium wave band is an independent band to the other one on the other side. And the FM is a completely independent band as well. So we've got 1, 2, and on the other side we've got 3 tuners, effectively. Although the one on the other side, the A, you can switch between medium wave and short wave. And the way they used to do this was to simulate stereo. They would transmit, and I believe there were about 100 stations in the States that did this. They would transmit, let's say they transmitted a signal on 100 megahertz, and they would tell you that they would transmit another portion of that signal on medium wave at, for example, I don't know, 1 megahertz, right? So what you do is you tune to 100 megahertz here. You would tune to 1 megahertz there, right? You'd put that on medium wave. And then you had to choose what you were listening to. And what you would choose then would be, here you would choose A plus B. And A plus B would give you this signal, this left signal on the left-hand speaker, and the FM signal on the right-hand speaker, okay? You could also choose just B, which means you just get FM that's tuned on the other side, or whatever is tuned on tuner B, or just A, which gives you whatever you've chosen on this particular tune on this side. Then you also have stereo down there for your phono pickup and your auxiliary input, and reverse stereo. And quite honestly, I don't know why you'd use reverse stereo. But anyway, you also have an on-off switch here. Then coming across here, you've got your medium wave, short wave switch, which I mentioned. You've got hi-fi and soft sound. This would be a tone shaping, probably cutting off the treble. You have a balance control over here, left and right. You've got a volume control here. You have a loudness switch on and off, so you can get some more bass at low volumes. Then we come across here and you've got a rumble filter. Rumble filter would be for low frequency, basically low frequency ghost signals that would come through. I can't really remember the full explanation of that. Scratch filter for the high frequency cutoff. Then you've got a few more selectors here. You've got normal and recorder. This has got a tape out, so normal or tape out. You've got speaker and headphone. This thing's got a headphone output over here, and you can select between your speakers and headphone. There's your bass and treble, okay? And then you've got another selector here, which is quite interesting because it will let you choose what it is you want out. You can have auxiliary, which you feeding in the back, phono. Then you have AM and AM. In other words, you can have AM on the right and AM on the left, and it'll give you AM and AM, or AM and FM. So you can have that pseudo FM stereo option, where you have FM coming out of the right and your other half of the FM coming out on the left on medium wave, and that gives you a pseudo stereo signal. I don't really know how good these were when they were operational, because obviously we can't get them to operate today. There is no transmission on using that system, but they certainly were built to the highest possible standard. I mean, this thing is a beast inside, and I'll show you. I'll open it up and show you. This thing, oh, and one more thing I've nearly forgotten. It's got an MPX signal here. You can actually have an external MPX decoder. So it takes your FM mono, or rather takes your FM signal, which is going to be processed as a mono signal here, but it goes out and it comes into two RCA jacks from your decoder, and that'll send one signal to the left channel, one signal to the right channel. So when you do have, or when you were going to get your decoder option, this thing was ready for that as well. Now, this thing doesn't have an MPX decoder, so we can only get FM mono on here. And the problem with this particular set was it was only playing on one channel. And the first thing I had to get my head around was, what exactly are we supposed to hear? Because I wasn't even sure that normal FM would be heard on both sides. If I just put that on FM AM and choose B, I should get just FM. Now, I wasn't even sure that I'd get FM on both channels. So what I did was I put it on auxiliary and fed a stereo signal in left and right, and I noticed I was only getting a signal on one speaker. Obviously external speakers. And so I realized one side was off. But this thing's working now, and I will, as I go through it, I'll show you the inside and I'll tell you what it was that had to be done. The reason I'm showing you this is really because this is such an unusual piece of equipment that, quite honestly, I was pretty fascinated by it, and I wanted to share it with you. I'm not going to do a repair or restoration video on this because it isn't necessary. Somebody in the past did a restoration on all the caps, did a full recap. They've actually done a few other things which I'll show you. Probably sort of things that I would have done as well. It's not bad. Now, I'm going to flip this around and show you the back. It's actually quite busy at the back, but it's really simple once you go through the details. The advantage here is they've got everything described on this panel over here. this thing here, this is just a wire hanging out of here. This is an AM antenna, and that's the description over there. It's an AM antenna, it's just a wire. So this would be your AM antenna for your tuner B on the front here. This one here is your FM antenna. So you would connect these two to a dipole. What they've got at the moment is they've connected this socket over here just to make it easier. That's for your FM tuner on the B side. You've got a record player. What have we got here? What is this? The player earth. You actually can earth your record player on there as well. This is these two are the RCAs for turntable 1 for magnetic pickup. This is turntable 2 for crystal pickup. You see over there. So depending on what kind of turntable you've got, you can choose whichever input you want. This obviously one will have higher gain than the other. Then we've got these two over here and that one over there. And if you follow the legend at the top, it says MPX out. So your MPX signal comes out of here and your MPX in goes in there. So you'd have your MPX decoder on the outside. Take your FM signal from here with stereo data on it. Do the decoding outside in the external decoder and feed it back in. Now to hear that, you would choose MPX on that front selector switch. We also then have auxiliary input over here. That's just a normal RCA stereo input over there. We've got playback, tape playback over here and tape record over here. So that's when you select in the front whether you want to do the recorder or normal. Here's a different tape recorder connection over here as well. Tape recorder connector with the DIN socket or DIN plug. So that's two options you have here. Then you've got a remote sub-balancer connector. You can actually have your a balance control outside of the unit, and that's over there. At the moment it's not in use. You've got your speaker connectors. These are the two grounds or negatives, and these are the two signal lines. And if you follow that legend over there, you connect one speaker to these two, another speaker to these two, and you can actually connect a center speaker, connect it to that side and connect it to that negative. So you can actually get a center speaker which apparently enhanced your stereo experience. Right, another thing, switch. This switch over here is an 8 ohm or 16 ohm speaker. That's indicated over there. Then you've got a hum balance for pickups, channel B hum balance, channel A hum balance. Now this would be to null out any hum that you have. You've got a socket, unswitched socket over here to connect for AC cord to connect some other equipment. When you switch on this unit, it switches that on as well. You'd probably use a turntable or a tape deck on there. The AC power cord over here, a fuse, and another antenna. This is the antenna for the other channel. On the right hand side, this would be the AM and shortwave antenna. And if you look inside, we'll see the inside a bit better. You can see transformer, there's switch over here, output transformer, some tubes, output transformer, and something over there. I'll open it up and show you exactly what's inside, and we'll look on the underside as well, because this thing is quite interesting. So here's what this beast looks like from the top with the cover off. And quite a few things become obvious very quickly. One is, look at the size of that power transformer. This thing can really deliver. It's pretty big for a receiver. And if we go along here, you've got that output transformer, which is quite beefy as well. There's the other output transformer. We've obviously got the, this is obviously a push-pull, so there's two tubes for the left channel, two tubes for the right channel. We've got the tuning condenser for the FM and for the medium wave on the B block of tuning. Now all this has got to do with channel B tuning, so FM and medium wave. Across here we've got medium wave and short wave, so that's the tuning condenser for that. These are single triodes. I believe it's an EC92 single triode tubes. Those are, I think they're they're 12AX7s. That's a 12AX7. These are another single triodes. We'll see what they are when I show you the schematic. So there's quite a collection of tubes over here. That socket there, I believe, is probably just for testing because there is nothing connected on there and I don't see anything indicated on the schematic. What we have in the front here are two magic eyes. Under there you can see all the tone controls, volume controls and switches. They've all been properly cleaned. Now as for restoration, what we can see here is somebody's already done a job here. They replaced a dual capacitor here with two capacitors. They took the can off and just fitted those two in there. There's another set of capacitors over here. These have also been replaced with discrete caps and placed in place of the can. Oh yes, that thing over there was a rectifier tube. Just remembered now. It's a rectifier tube, and they removed the rectifier tube, and on the underside they put discrete diodes, two silicon diodes instead of the two diodes inside the rectifier tube. They've also put in series resistors with each line to drop the voltage slightly, because with the diodes you'd get less voltage drop than with a rectifier. Then of course you've got the IF transformers, which I have not touched. In fact, none of this was touched, and the reason is very simple. The problem with the right channel that was dead was actually not as serious as I thought. However, it took a hell of a long time to figure that out. My first fear was that it was the output transformer, and the reason is this. I take out these tubes. These are ECL80s, and an ECL80 is a tube that has a pentode and a triode in one envelope. So the way they use this is they use the triode as part of the preamp, and then they use the pentode as the power tube. So if you take pin 6 of these, that's your the anode of the power tube, and you use the system that I mentioned to test for output transformers. You feed a signal from a signal generator onto that pin, connect a speaker, you should hear the tone. You can use, now obviously this isn't push-pull, so you can use either. In fact, you test them on both and your signal should come through. When I did that, I'll indicate above how that test works, but when I did that, I got the signal coming through, the tone coming through with this side and not with that side. So the first test was, perhaps it's the first thing I thought was it's the power transformer. Then I realized that after the power transformer, there is quite a bit of switching going on and quite a bit of wiring going on. So I did a quick test. I removed these tubes and tested for anode voltage. Now, if I do that, I will know that the primary of this transformer is fine. And I had anode voltage. I had B+ on the anodes, so I knew the primary was fine. So the problem was obviously on the secondary. And that's when it got interesting. But I'll show you the underside and give you an idea of what it looks like underneath and how bloody difficult it is to get anywhere on this thing, because it is very compact. Now, the one thing that was good is that I actually did find a schematic for this. It was quite difficult, but in the end I found a PDF document which was from a CD that has a huge number of Pioneer tube receivers, and each one, well, there's a page or two for each of the receivers, and this one is on there, fortunately. Now this whole complexity here was to try and get people to enjoy stereo from what was effectively a mono transmission. FM stereo. Now we think about FM stereo now as something quite common. You get it on just about anything you want, including a mobile phone, but back in those days they went a long way, and Pioneer certainly went a hell of a long way, and ended up with this result. Brilliant. Brilliant. Right, so this is what this thing looks like from the underside. And as you can see, it's pretty messed up. Quite a nightmare, actually, if you need to do this. And the only way to do this, as anybody who's done this will know, is you do it one component at a time when you restore something like this. And that's exactly what somebody's done here. They've restored or replaced the electrolytic capacitors over here. Quite a few. Everything that was electrolytic seems to have been replaced. They've used the axial ones, which is probably true to the ones that they had here originally. They've replaced all the paper caps. Those white ones are filmed caps and they're all new. So they've done quite a job, and this was done, I believe it was done about 10 years ago, according to the owner. Everything is ceramic. The ceramic caps were left in place. I don't see many resistors changed. Maybe that one was, and that one. But other than that, they've kept things pretty much the way it's supposed to be. And if we look here, as I mentioned, the underside of that the tube rectifier, they've put in 2 silicon diodes with series resistors in there. 5 watts, I believe. What does that say? Yep, those are probably 5 watts, just to drop the voltage a bit, to make it more in line with what the voltage the B plus would have been with the tube rectifier. So that's all done nicely. The filter caps, those 2 that you see from the top over there, this is obviously where a can was placed. There's another set of filter caps. Where is it? Damn, can't find it. Actually, I think it's over here. Over there, I think, is where the other filter caps were. Anyway, they did replace the filter caps. They seem to have cleaned up quite nicely after themselves. Nothing too serious there. They used a different, they used those yellow ones over here. There's some micro caps here that were probably, those are probably original, those yellow ones. Those very, very seldom go out. A couple of resistors, you can see that metal film resistor, that blue one there. That's obviously new. But other than that, this thing is pretty original, and the recapping job was pretty well done. I'm not sure that I could have done any better. Not that I'm a reference, but I like it. I like it. I've seen some stuff that really makes me cringe, and this one doesn't. This one makes me cringe for a different reason. If I had to do this, it's a hell of a job to take on. As I said, you've just got to start on the one edge and work your way through, one component at a time. When you look at something like this, it's daunting, but if you break it down, it's doable. Switches are still sort of the open wafer switches over there. The pots, multi-layer pots over here for, I believe that's the tone controls. Yeah, I think that's tone controls. The balance will be a single one, and then the stereo volume controls over there. Another wafer switch over there, the power switch down below with the death cap. They replaced that for a safety cap, I see. That's obviously something new. The hefty power transformer over here. It's pretty large. And so what was the problem with this? Well, it's a very short story for a very long job. The outputs, I'll go through this when I show you the schematic, but the output signal, I traced the output signal to the the actual primary of the transformer. And so the answer was that the secondary wasn't getting to the speakers. Now, the secondary comes out and goes through two switching systems. The first one is the 8 ohm, that one there, 8 ohm or 16 ohm. And then it also goes to the front where you get your selector between speakers and headphones. And between one and the other, including the two switches, there were some bad solder joints. And the switch, this particular switch here, was a bit buggered. So I had to remove it, clean everything inside, rebuild it, and put it back in. Now, if you look at the space constraints where all these wires travel across here, you'll understand why that can be pretty daunting. This then goes all the way to the front, and it goes to the speaker selector switch at the front there. So, very simple job, but a very tiresome one. But fortunately it works, and I'm going to show you how it works in a minute. I'll just quickly show you the schematic and give you an idea of what this thing is all about. And that's the guts. Right, here we have the schematic for this receiver. And as I mentioned earlier, I got this off a document that I found on the web, but you can search for it. It's called Pioneer-Circuit Diagrams Volume 1. And it has, I don't know, it's about 40 pages of schematics, and this is one of them. Now, when you look at this, a little bit like looking at the underside, it looks a bit complex, but when you break it down, it starts making sense. So let's start. This section here is the first AM receiver, so AMA, as you can see over there. So this is the left part looking from the front, okay? And what you'll see here is a normal receiver. It's got no front-end amplification here, it just goes through those coils. And in fact, the switch we have here, the SL1, that switch there, that switches in either just the top coils or the bottom coil, depending on whether you're going for shortwave or medium wave. So this is the dual AM receiver, medium wave and shortwave. That SL1 over here is the selector switch, and that switches in the respective coil for the front end, and it also switches in the respective oscillator circuit so that it oscillates either on the medium wave band or on the shortwave band. So signal goes through there, through that, which is the IF amplifier. That's the first IF transformer over here. That is the first IF amplifier. Another IF transformer. This section here then is where your audio is taken out, and that then goes to the respective, you can see it going down here, down here, down here, and it goes to the mode switch, the selector switch. Okay. Next, at the bottom here, we have a similar situation. There's your antenna input for AM-B, so this is on the right-hand side of the receiver looking from the front. AM, there's no selector switch here because it is just medium wave, no shortwave on the side. And what you have here is that's the soft hi-fi switch, so that soft hi-fi switch only operates for the medium wave. And what else do we have here? This section here is the FM receiver. There's your antenna inputs, there's a front-end amplifier, there's an oscillator section and a mixer section. I won't go through all the details because it is really not that necessary. But ultimately what you get is these signals will go all the way up to selector switches over here, depending on what you select, which mode you select, and so on. What it also has is this section. There is this section over here, and that is your MPX driver. So this creates the MPX, or removes the MPX filtering, does the MPX filtering to create an MPX output. Now, if we go to this end here, you'll see MPX out over here. Now if we follow this line here all the way through, still on there, still on the line, still in the line, and it comes down to here. So that point there is your output of this MPX driver. Okay, and if we go back to the front end and we go to MPX in over here, you see that was the out at the top, that's the in, and that's the in for the one side. If we look down here, where is it? There's the other MPX in. So it goes out as an MPX signal, it comes in as audio, because if you follow that line there, it comes down to here, which is your selector switch. So when you select MPX, you're basically selecting another audio input. I would hazard a guess and say that you could actually put in a normal line input, stereo line input there, like a CD player, and you'd get exactly that coming out of your speakers in stereo in that case. So basically we've got the first AM receiver with shortwave as well, medium wave and shortwave. We've got the second AM receiver over here, which is just a medium wave for the right hand side. You've got the FM receiver over here, which is on the right hand side. You've got the MPX driver over here, and then everything comes up to here to these selector switches over there. And if we follow these selector switches, what you'll see is that you're getting a signal through that capacitor there, that comes from the bottom switch, and that capacitor there, which comes from the top switch. Remember, you're dealing with left and right, and they go into the mode switching, and then everything goes into this section here. Now this section here has a couple of switches. That first switch there, which is a dual gang, double pole, double throw switch, and that's called SL4, and if we go up to here, SL4, at the top here is tape monitor. So that's where you're selecting your tape monitor. That one over there, those two there, which are also ganged, is called SL5, and SL5 up here says loudness. So that's your loudness switch. And as expected, what your loudness switch does is it either switches through direct, or it switches through it switches in a capacitor resistor network, which allows you to either cut the highs or let the highs go through. So in other words, if you put loudness on, it'll cut the highs, give you more bass. Now, what else do we have here? We've got the volume control here, again dual gang. And then we've got the channel separations. You've got your first preamp stage here, which is a 12AX7, half of a 12AX7. The other half of the 12AX7 is over here. That's a simple triode amplification stage. It then goes here to the tone controls. There's a treble control and a bass control. This looks like a Buxendol tone control. Yep, I think it is. Modification of it. You come to here, and this switch isn't marked, but I think it's SL6. It's a scratch filter. Yep. So that also does something to the high end to reduce the high end and act as a scratch filter. And then you get to this stage, which is fairly interesting. And we'll look at one half. This here is one half. It's one channel, and the other side is at the bottom. And what we have here is something very interesting. You have this tube here, which is a triode, and it's just acting as a preamplifier. And this triode is actually V7A. Now V7 is that tube over there. So what they've done is they've created a system where this tube, which is the ECL86, which has a triode and a pentode, they're using the pentode part as the power stage. Over there is one tube, and over here is the other tube. And the other half of this one is there, and this is the other power tube, and the other half of this one is there. So what happens is you can't actually test for audio at the input of the grid over here of this tube or that tube with this tube, with these tubes removed, if you know what I mean. If you had a separate triodes over here, the signal will still be processed, blah blah blah, and it would go through to that point. And if you remove that tube, you could measure at pin 8. There's your grid, pin 8, and there. You could actually measure the signal at pin 8, but it actually needs that tube to do the preamplification stage. This particular triode here is acting as a phase splitter, so you can get the positive signal and the negative inverted signal for the push-pull output stage. And then you have your your output transformer there doing the push-pull function. Afterwards, the signal comes out here. There's a feedback path over there, through that resistor. But if you look at it, you've got a 16 ohm output or winding and an 8 ohm winding, and you select between those, and then your signal comes down here, down here, down here, and it goes to the selector between the headphones and speaker. And if you choose speaker, that signal then goes to there. If you choose headphones, then it goes up to here, and it goes through this resistive network to drop the signal down for headphone level through a 100 ohm resistor. But it also has, and with the ground in the middle, a 10 ohm resistor over there and a 10 ohm resistor over there. And the reason for that is, you know, you should not operate tube gear with no load. Now, if you're using headphones and you select headphones, your speakers, whatever speakers you have over here, are out of circuit. So you need a load for your transformer and therefore for your output tubes. And that load, the minimum load there, will be the 10 ohms. The maximum load, I beg your pardon. Yeah, because if you do have headphones on here, then that adds to the load and it brings this whole resistance a bit lower. But it means you never run this the amplifier section without a load. And so that's pretty well thought of. I'm not quite sure what kind of headphones will work best on here. There's more descriptions here about how they've measured the voltages and current ratings and ripples and everything else. So it's actually pretty complete. Furthermore, you have this top section here describing what kind of components and the legend for which components, the component ratings like less than 5%, less than 10%, and so on. There's your legend for the switches and the mode, the selector, the VRs that they used. You got a balance control, volume control, that's A and B, that's stereo, treble control, that's stereo, bass control, that's stereo, and the hum balances are VR3 and VR4. Now, just out of curiosity, where are the hum balances? I'm actually not sure. It took a while to find it. I should have looked, it's obvious. Here we have the hum balancing pots, VR3 and VR4. And what they're doing is, this thing is producing, this transformer is producing 5.5 volts at 0.3 amps, so it's a heater voltage. And it's a floating transformer. It's AC volts and it's floating. Both of them are floating. Now what they do, you do a hum balancing by putting a resistor in there, 100 ohm resistor, and center tap to, or the wiper to ground. Actually, no, it's not to ground. What they've done is they've put it to the cathodes of certain resistors. So that goes to V4 and it's connected to K1. So V4 is over here. Okay, that makes sense. V4 and V5. Here we go. This is V4. It's a 12AX7. I didn't actually go through this. This is actually the magnetic and the crystal pickup. This is the phono preamp, left and right. So that's phono preamp. And what you have is you create a hum balance pot to feed the heaters of these two tubes separately. These are fed separately so that you can reduce noise as much as possible, because this is the high gain stage to bring your pickup level to line level to be more or less equivalent to the other input levels that you have from this receiver and from the respective inputs like the auxiliary input and the MPX input. So you are raising, or rather creating, a cleaner supply, a humless supply to the heaters of these two tubes to make them as quiet as possible. Over here you've got the external balance control, which is that socket that comes out the back, and you can fit an external balance control to balance between left and right. Now, why is that important? Well, if you're listening to this on that pseudo-stereo system where you've got FM on the right hand side and you've got the sort of the stereo version of FM, or the half channel of FM on your AM radio, on your medium wave on the left hand side, the actual volume levels might be quite different, because FM is probably going to be higher than AM, because AM is going to depend on how far you are from the receiver. It's amplitude modulation, so your signal gets the variation in signal level is very dependent on distance, and that means you may have to increase the left hand and reduce the right hand. In other words, increase the medium wave component versus the FM component, and that's where your balance control becomes useful. Here's another bit of information. That's 12 watts output. That will give you 13.9 volts. And so yeah, that's it. That's more or less the whole thing. There is one more thing. There's the sub balancer. That's the external balancer that you plug in, and basically all it is from 3 goes to the wiper, 2 goes to one end of the pot, 1 goes to the other end of the pot, and I'm sure at the other end somewhere this thing is to ground. So 3 is the wiper. Where does 3 go? 3, yep, there it is. So that's your left signal, right signal, and if you've got it straight in the middle, you've got an equal balance between left and right, and your wiper goes to ground through a capacitor, 30 microfarad capacitor, which means you are draining signal to ground. You're not creating a DC path to ground, but you are effectively increasing one side versus the other. And that's it. I mean, ultimately, when you start looking at this thing piecemeal, it's, well, I should be careful what I say. It's not simple, but it's a hell of a lot simpler than it looks when you first look at this whole thing. One more thing here. Yep, here we go. This is the main supply, 255 volts, 0, 255 volts. So there's a 510 volt across here. But they use a GZ34 rectifier tube. This is directly heated cathode with a separate 5 volt AC supply, and that point there, these are basically 2 diodes, and that point there then is your B+, the B+, which goes to the first filter can, etc., etc., etc. Pretty normal. And you've got a whole lot of other supplies over here, low voltage supplies. These will be to probably be for some heater windings, yeah. V1 to 3, 12 to 15, 17. These are heater windings. Heater supplies. Here's another separate heater supply for V6 to V10. So this thing has got quite a complex transformer. It's very well designed. It's redundancy to the extreme, in my opinion, but I suppose when you're designing something at a time where nobody knows where the future is going to go, I suppose it's best to prepare it for all possible deviations that that path might take, and that's what they've done here. They've prepared it for normal AM and FM, and AM has got medium wave and short wave, and they've given it the possibility of doing that pseudo-FM, stereo FM thing. They've given it MPX output with possible MPX decoder. It's bloody well thought of. I mean, I doubt very much whether today you'd get anybody in a company financing this kind of these options. But I suppose if you're in the design business, you have to keep designing regardless of where the technology seems to be going or not going. We've had a lot of that in the past with things like Betamax and VHS cassettes and the type of CD formats that ultimately became the norm. So I guess, yeah, this was one of those times when they had to do a bit of overkill, and they've done a great job. Anyway, enough of the circuit for now. Right, we're ready for testing. Put the supply on, full supply, no current limiting, not needed. I've got a little wire for the antenna, no big deal. I haven't put a dipole in or anything like that. And I've got my mini whip for the AM. The two antennas are linked together. So let's see what we've got. I can see the lights on there. Give it time to warm up. The balance is in the center. I've got it on mode B, B being that side. I've got this thing on FM. This is set for FM AM. So here we go. Trying to get some voice radio. Bloody hell, everybody wants to play music. The sound is great, I just can't leave it on there for long because of the copyright claims. Bloody hell. Alright. FM coming on there. There's the Magic Eye tube. It's tuning great. Everything actually, I just want to wait to get some voice radio on here. But in the meantime, I'll put this on A. And A is on medium wave. Put it on FM, on short wave, but leave it on medium wave. And tune it. Music again, right. Something from probably Morocco. This is Canary Islands. Alright, here's the Spanish station, Canary Islands, and it actually picks up fairly well. Now, bear in mind, this mini whip does help a lot. I've got this on A, so I'm receiving through the A tuner in the mono mode. So A, B will be whatever's on this side. A plus B joins the two. Now, I actually got it wrong when I described it initially. This function of mono is, if you put it on mono here on A, it'll give you what's coming on out of this tuner, and it'll give you that in mono on both speakers. If you put it on B, it gives you what's coming out of that tuner, and it'll give you that on both speakers. If you do A plus B, it literally sums the two and gives it to you as a single equal signal on both speakers. If you want to use the system they had, I'll show you in a minute. Let me just try and get some voice radio on this side. Just some comments. I mean, the reception, the sound is astounding. Pity I can't leave it on there, but the quality of the sound on this thing, on the FM, is astounding. It's really, really, really rich. It's fantastic. And I haven't even put in the loudness, which would probably make it too boomy. So yeah, this thing was built to really perform. And what I've noticed here is when I have both of these on, when I have this on A and B, our A is a lot lower than B. So our medium wave reception in terms of volume is a lot lower than the FM reception. So I've got to put the volume up there. This hi-fi soft switch affects that sound. The loudness, I don't know if you can hear it. It actually brings quite a bit of noise in, but it does raise the bass level. And if you were going to use this on that pseudo-stereo, what you would do is you'd put this side to the signal you want. Let's do that. Alright, you'd put this one to the signal you want. And now if you put it on normal stereo, what you're getting is this channel on the left coming out of the left, that one coming out on the right. And this is your balance, so you're getting the two mixed, and you would get a pseudo-stereo sound out of that. But as you can see, because of the different levels, I need to keep the balance control very much on that side. Otherwise the FM just swamps it. And that is normal. I can also, I mean, we're hearing this the Spaniard going on. I can also put this on AM, and now the AM tuner here is working, and I can tune it to the same station. There. This one's actually a bit lower than that one. But if I put it on stereo, what I've got is both signals. See the difference? What I've got now is I've got the same reception from one tuner and from the other tuner on the left channel, right channel. So that's how it goes. Anyway, this is really not something that's too easy to demonstrate with all the copyright problems we're having. But if I leave that on FM AM, here's my AM. This is all Canary Islands. This is the one Madeiran station. If I put it on shortwave, absolutely zilch this time of the morning. But in the evening I have received something. The comment about the shortwave is that it's not particularly sensitive or selective. The reason is you've got this thing's going all the way from 3-point-something megahertz to 12, 13 megahertz on one band with no fine tuning. So as you can imagine, if you do find a station, it'll be a stronger station, and you probably have to fiddle quite a bit to tune it in properly. So this is not really a shortwave set. On this particular side, if you put that on B, this is on FM. Very good reception, incredible reception, just with a little piece of wire. I haven't even got a dipole on or anything like that. that is, you probably can't hear it because this is coming through the microphone, speakers on the floor. The sound is amazing. And that's about it, guys. That's basically a short demo. What we have here is a very, very good FM receiver. Pretty good medium wave receiver. Not so good shortwave. Depending on what sort of antenna you use, you probably would be able to improve that. But this is a more hi-fi-ish receiver than most of the old sets that I restore. They do go for the wide bandwidth sound, and you can hear that quite clearly. The quality of the sound is astounding. When you get a strong FM station and you give it some treble, the treble is there. Not like some of the other ones where you really have a cut. This thing's got a fantastic response. The Magic Eyes are working perfectly. Everything is working actually perfectly. So it's been a pleasure to work on, simply, or mainly because of the novelty factor. I'm really impressed with this receiver. I've learned something new. I've learned about this whole range of pieces of equipment that Pioneer did that I knew nothing about. I've subsequently found more service manuals. I gave volume 1 as a reference in the video, but if you go to wherever they are, where you find it, and you just change to volume 2, volume 3, volume 4, you have 4 volumes of schematics. So it's pretty useful. I've downloaded them. Never know when they come in useful in the future. This has been a rather long and strange video because this is a complex and strange piece of equipment, and I hope you've enjoyed it. And I will be back soon with whatever. You never know. That's the beauty of being in an island of 100 or 250,000 people, where you can actually get variety, if not quantity. Have fun, and look forward to having you back soon. Bye for now.